Hey everyone, welcome back. So today in my video I am going to discuss about something resistance in series and resistance in parallel. So before understanding resistance in series and parallel, there are a few terminologies that one should have minimum idea on. That is current, voltage, resistance and resistivity. Very quickly we will discuss briefly. Current is nothing but charge flowing per unit time. Per unit time. Current is represented as I. Okay, current is represented as I, and we know that I is equals to Q by T. Q means charge, T means time, and we also have another formula. Q is equals to Ne, where N stands for number of electrons, E stands for charge of electron, N stands for number of electron, Q stands for sorry yeah charge of electron, Q stands for the charge, total charge. Okay, now how is this current measured? Current is measured using an ammeter, and this ammeter is connected in series with the circuit. Okay, I'll show what is in series. Coming to voltage is with V is equals to IR. Current flowing through resistance, nothing but voltage. Okay, voltage is measured using voltmeter. Okay, voltmeter. And then coming to resistance, R, we have a famous formula. R is equals to rho L by A, where rho stands for resistivity and then L stands for length, A stands for area. Okay, and one thing what should be noted here is resistance depends on resistivity, length of the conductor and area. Okay, we can say R is proportional to R is proportional to resistivity, proportional to length and inversely proportional to area. Okay, coming to resistivity is nothing but is the nature of the conductor, and point to be noted here, it depends only on temperature. Resistivity depends only on temperature, it doesn't depend on any other factor like length, area of cross section, etc, etc. Okay, so these are the four main important terminologies. Voltmeter is connected in parallel. Okay, now let me show you what do you mean by series and parallel. I am rubbing this one. Okay, and resistivity symbol of course is rho. Okay, this is the basics. Now coming to the actual topic, that is resistance in series and parallel. So just now I said you that ammeter is in series, voltmeter is in parallel, correct? So suppose this is a resistor. Okay, and we know that this is a battery symbol is made up of many cells, only one cell is this one. Okay, and then this is bulb symbol, correct? And then this is the resistor symbol, and then this is close switch, open switch. All this is basics that everyone knows. Okay, now if suppose I wanted to measure the current across the ammeter, I have to connect across the resistor, or I wanted to measure the current, then I have to connect an ammeter in series with the resistance, means along with the resistance I have to connect it. If I wanted to measure voltage, I have to connect it parallel to the resistor, like this. This is the meaning of parallel attachment, series attachment. Okay, so if I connect like this, the current will be measured in the resistance and even the voltage will be measured in the resistance. Okay, now let me make it in two columns. That is, first one is series and the another one is parallel. Okay, one basic diagram that is there for both series and parallel is this one. There is a resistor. I am taking three resistors. Okay, and then I am connecting a battery or a cell to it. Okay, this is one thing. Here I am taking another circuit in which I am connecting the three resistors in parallel. Okay, just now I said parallel and series representation I have shown you, correct? So this is parallel combination, this is series combination. Okay, let these all resistors be identical. What do you mean by identical? Means all the resistance are same, R. And here also let all the resistance be identical. Okay, it is given that the resistance is identical. Okay, resistance is identical means nothing but all the resistance are same. Now let me derive the formulas for both the cases. Okay, we know very well the basic formula, that is V is equals to IR. This is the basic formula that is in the current electricity chapter. V is equals to IR. In this, in series I remains constant, means whatever amount of current is flowing through R, this one first resistance, same will flow through all the others. When coming to parallel, voltage remains constant, means current is flowing like this. Suppose current is flowing like this. Here current splits. Suppose total amount of current flowing is I. The current flowing through this is I1, I2, I3. But voltage across all the three resistors is same. This is another fundamental that one should remember to derive these two. Okay, what is that? In series I remains constant, in parallel V remains constant. Now coming to this one here in series, applying the basic formula, V is equals to IR, I remains constant, correct? So can I say V is proportional to R, directly proportional to R? Now let me say total, this is having total voltage VT, or I can even say Vs. Vs is nothing but voltage in series or total voltage, okay, which is nothing but V1 plus V2 plus V3, correct? Because voltages are different, current is same, voltage is different. Now as voltage and resistance are directly proportional, that is it is directly depending, if voltage increase resistance increase, that is the condition. So can I say R total or RS? This is not divided by, this is the symbol of R. Okay, don't think it is divided by. RS is R1 plus R2 plus R3. In our condition R1, R2, R3 are same because resistance is identical. So can I say R plus R plus R, which is nothing but 3R. This is resistance in series. So therefore resistance in series is 3R. Okay, coming to this one, parallel combination. In parallel combination, what I have said is same formula, V is equals to IR. Here in parallel V remains constant. In parallel V remains constant. So can I say I is inversely proportional to R? Why? Because IR remains constant. I is equals to 1 by R. If I am removing the constant or neglecting the constant, I is equals to 1 by R. So here we are getting that I is inversely proportional to R. So total current flowing I total is equals to I1, I2, I3. I1 plus I2 plus I3. Okay. Now here we took V proportional to R. So therefore Vt is V1, V2, V3. RT is R1, R2, R3. But here we are taking I is inversely proportional to R. Not by my own wish. It is the rule that is there. Correct. So can I say in the place of It, can I write 1 by RT or 1 by RP? RP is nothing but resistance in parallel. Okay. 1 by RP is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is the point that is to be noted. Okay. So this is the basic formula for resistance in parallel. and this is the basic formula for resistance in series. Okay, this is resistance in series, and then this is resistance in parallel. For us, they have given that all the three resistors are identical, so I am taking here 1 by Rp is 1 by R plus 1 by R plus 1 by R, which is nothing but 3 by R. This 3 by R is nothing but 1 by Rp. We want Rp, so can I say Rp is R by 3. We have to reciprocate the final answer, because the final answer whatever we are getting is 1 by Rp, or 1 by resistance in parallel. Many people forget to reciprocate here. They just write it as 3 by R, which is wrong answer. Okay, so I hope you have understood. These are the basic concepts for resistance in series and resistance in parallel. Okay, thank you.